Televisa presenta.
Hello, we are going to talk about the centripetal motion. As we can see, centripetal motion is when an object moves in a circle and a centripetal force pushes it toward the center so that it doesn't shoot out in a straight line. This force causes the object's velocity to constantly change direction, keeping it on its circular path.
Now let's look at one of the key concepts, the circular motion. This is described as the motion of an object rotating along a circular path and also can be uniform when the angular velocity of rotation and speed will be constant, or non-uniform when the speed of rotation is constantly changing.
Now I will talk about the other key concept, centripetal acceleration. Centripetal acceleration is defined as the property of motion of an object moving in a circular path. It's any object that moves in a circle and has an acceleration vector pointing towards the center. And this is the formula for this acceleration.
The next key concept is the tangential velocity. As we can see, it is the instantaneous velocity of an object moving a circular path directed to the tangent to the circle at any given point. Also, its relation to the angular velocity is this formula, that is v is equal w per r, where w is the angular velocity, where its characteristics are the constant magnitude, where the velocity of the object is always the same, and finally the variable in a direction, which is the direction of the velocity change, constantly always pointing tangent to the circle.
Oh my god!
Okay, the last one will be path radius.
Love in 1,000 different flavors. I wish that I could taste them all night.
Okay, it is the distance from the center of the circle to any point of the moving object, and its influence on the centripetal forces is the larger the radius, and the smaller the centripetal forces needed to maintain the same circular motion.
Señora madre Casa, le venimos ofreciendo clarasol, vino, champú, suavitel. Quiero para todos los bailadores con esta rola que dice.
Okay, one of the key elements is the tangential velocity, which is the constant velocity that changes direction, measured in meters per second. Another element is the centripetal acceleration, which is directed toward the center and calculated as measured in meters per second too. And finally, the centripetal forces that keep the object in the circular trajectory, also directed toward the center and calculated as where is the mass.
Now we will talk about centrifugal force. It is the force that keeps an object in motion along a circular path, constantly moving towards to the center of the circle. This implies that although the object has a constant velocity, its direction changes continuously, resulting in an acceleration called centrifugal acceleration.
Oh my god! Wow!
The following are the causes, effects, and equations related to centrifugal force. Causes of centrifugal force. Centrifugal force originates from several types of interaction, depending on the situation. Common causes include tensile force, for example, in a rule that keeps an object rotating in a circle; gravitational force, such as the force that keeps the planets in orbit around the sun; frictional force is the case of a car taking a curve where the friction between the tires and the ground allows it to turn. Electromagnetic force. In systems that charge particles moving in a circular trajectory is in a particle accelerator. An example will be this.
To continue with this would be the centripetal force effects, which we start with changing the direction of velocity. Since the acceleration always points towards the center of the circular path, the direction of the object's velocity is constantly changing. Circular trajectory. Without the centripetal force, the object would move in a straight line, so this force is essential to keep it on a curved trajectory. Sensation of outward force. We often experience an apparent outward force on a rotating system, known as centrifugal force. which is actually a perception of the object's inertia.
Centripetal motion is produced by centripetal force, which changes the direction of the motion of an object. As we saw earlier, centripetal force is a component of a force that acts on an object moving on a curve and pulls it toward to the path of the center. For this example, I will use a marble and a glass. The goal of this example is to lift the marble without touching it. In this part, I will demonstrate that when you place the marble inside of a cup and move the cup back and forth either horizontally or by moving it in a circle, the marble follows the same trajectory as the cup but without touching the cup directly. The cup, when moving in a circle, provides a centripetal force that keeps the marble in circular motion. Horizontal motion can also be observed when the cup and the marble follow a circular path in the horizontal plane.
That will be all for our part.
Vamos a bailar algo que está perrón, que toda la gente brinca de emoción, se mueve muy rico con esta canción.